Okay, let's take a look in this example. The researcher recorded the amount of time each bird spent in a plane chamber during 60-minute season. Suppose the study produces a mean of 34.5 minutes on the plane chambers with sum squared 150 for a sample of n equal to 18 birds. Construct 90% confidence interval to estimate the mean amount of time spent on the plane side of the population bird. Okay, so we are constructing a 90% confidence interval. Well, there is a formula for confidence interval. It doesn't matter which formula table you look into. Okay, any statistics book there is a formula table, and that formula table has a formula. So I'm gonna actually put down that formula first here. So we're gonna find out which formula we're gonna use. So for example, C for confidence, I for interval is equal to sample mean plus and minus critical value times standard error of the mean. Well, some book they have a sample mean as x bar. Okay, some book this critical value, well, you have it in every book. You have z alpha over 2 or t alpha, and of course this one is s over square root of n. Now we have clearly given sample mean, so that would come here. Okay, now critical value, well, there is a two table actually. There is a z table and t table. Question is which one we look into here. So that is how we actually come up with the decision that which table we have to look into. Well, if the problem says normally distributed or sample size is bigger than 30, we go for z table. So in this case, we just gonna erase the z thing because we are not looking into z table because it's not normally distributed. Okay, so then we have one option, t table, t distribution. Okay, so we're going to use the t distribution. Now the next one is standard error of the mean. So well, we have s. No, we don't have s. We are given as a ss, as you clearly see. We are given as a ss. So what are the information given? I'm going to pull that, write that down on the bottom here actually. So information is given as a m is equal to 34.5. SS is given as a 150. Also given sample size, which is 18 and 90% confidence interval. Okay. All right. So these are the information is given. So what do we know so far? We know the sample mean. We know this one here. That's lovely. We don't know the critical value. So how do we find the critical value? Well, we're going to use the t table. But this one is s. We don't have any s. We are given as what? We are given as a sum squared. So we know s can be found like this: square root of ss over n minus 1, 150 over 18 minus 1, 18 minus 1. So if we get help of technology, just any smaller calculator is going to work here. So I'm going to put down second x squared and n over d. So 150 over 18 minus 1, 18 minus 1, enter. So 2.97. So 2.97. So it's approximately 2.97. I want to mention that this square root stays all the way on the bottom. Okay, and all right, so 2.97. So we have our standard deviation, as you clearly see. Okay, but we need standard error of the mean. So standard error of the mean is equal to 2.97 over square root of 18. This time we don't subtract 1. So we need a calculator one more time here, as you see. Okay, so we do 2.97 divided by square root of 18. So 0.70, approximately 0.70 is the standard error of the mean. Okay, so now we have everything. We just basically, this time is directly is given, this one is given. So we are ready, except the critical value. So how do we find a critical value? Critical value is, we go to the table. So let's take a look here. That's how we do this. So 90% confidence level. So this is not alpha level. This is 90% confidence level. Alpha level is the significant level, which is the remaining extreme one. Okay, extreme one to the right side. So, just a little bit on this video. I want to make sure that you understand what is going on here. So we are looking for a confidence level from point A to point B, point A to point B. This is what we are looking for. 90%. We know inside is 90%. We're looking for confidence level that is going to fall 90%. We're going to be confident 90%. So what is the alpha? Alpha is going to be basically 5% plus 5%, 10%. So 10% is going to be the alpha. So we're going to convert into decimals, 0.10. So that is the alpha. Remember, this is a 5% and this is a 5%. In order to find that critical value, this point, we need that actually. So alpha, so we have alpha 0.10 and degree of freedom 18 minus 1 is 17, and we go to the t table and get the critical value. Once we get that, we are done. We are ready to actually get the answer. So we go 0.10 and 17. So let's take a look here. So it seems like 17, yeah, 17, 0.10, and clearly that's a 17, and this is under 0.0. So 1.740 plus and minus 1.740. So that is the critical value. Now we have everything actually. So we are ready to actually plug the things in. So I'm going to write down the formula again. Critical confidence interval is equal to m plus and minus t value or critical value times standard error of the mean. So we are going to actually put down m is the sample mean, as you clearly see is given 34.5 minus critical value, that's the critical value 1.740 times standard error of the mean, that's the standard error of the mean we found, 0.70. You're going to have one interval and there is going to be another interval. 34.5 minus will be plus. Everything else will stay the same. Okay, so we're going to have a two interval, as you clearly see, two of them actually. Again, we can use a little bit of calculator here. So we do 34.5 minus 1.740 times 0.7. Enter. So clearly we have 33.282. Let's take a look on the next one. So I can erase, delete, or change the sign. I'm going to do it again. 34.5 plus 1.740 times 0.70. 35. So this one is higher. 35.718. Okay, so we actually receive two interval, as you see down here. So this point here, smaller one, 33.282, we are 90% confidence that our population mean is going to fall between 33 to 35. As you clearly see, well, it's just approximation down here. So That is what it says. Well, how do you write as an answer? We can interpret it. I just said it. Well, confidence interval is equal to, you can say 33.282 to 35.718, or confidence interval is equal to 33.282 comma 35.718. Otherwise fine. And how do you interpret it? We are 90% confidence that the true population mean is going to fall between 33 and 36 approximately.